Three announcements hit the robotics world this week. Any one of them would have dominated headlines on its own. Together, they reveal something much larger. NVIDIA unveiled a complete humanoid robot platform. It released an AI model that understands the physical world. And it introduced a new chip powerful enough to bring data center class AI into a laptop. At first glance, these may look like separate product launches. They are not. They are three pieces of a single strategy built around one idea: physical AI. And NVIDIA is positioning itself at the center of it. Building a humanoid robot today is incredibly difficult. You need a mechanical body. You need hands capable of sensing touch. You need cameras, sensors, powerful onboard computing, and software that can coordinate everything in real time. Most research groups build these components independently, spending years solving the same engineering problems. NVIDIA decided to eliminate that barrier. The company approached the challenge in two parts: the body and the brain. For the body, NVIDIA partnered with Unitree. The resulting platform is based on the Unitree H2, a humanoid robot that stands nearly 6 feet tall and weighs around 150 pounds. The robot features 31 degrees of freedom throughout its joints, allowing for highly complex movement. The hands come from Sharper, a robotics company specializing in tactile manipulation. Each hand contains pressure-sensitive fingers capable of detecting touch and texture. Together, the hands add 22 more degrees of freedom. Combined with the rest of the platform, the system reaches an impressive 75 degrees of freedom, approaching the complexity of human movement itself. Inside the robot sits NVIDIA's new Jetson Thor computer. Powered by a Blackwell GPU and equipped with 128 gigabytes of memory, it delivers workstation-level computing performance inside a humanoid chassis. Running on top of that hardware is Isaac GR0T, NVIDIA's robotics software stack responsible for perception, learning, reasoning, and movement. Then came the number that surprised everyone. The complete research platform is expected to cost roughly $29,900. For a 6-foot humanoid robot equipped with tactile hands and an onboard AI supercomputer, that price is remarkably low. Institutions including Stanford, ETH, Zurich, AI2, and UC San Diego have already committed to using the platform, with shipments expected to begin through Unitree in late 2026. There is one important caveat. NVIDIA did not present the H2 as a finished consumer robot. It was shown as a reference design, a foundation researchers can build upon rather than a polished product performing acrobatics on stage. But that distinction may not matter, because every university and research lab that adopts the platform learns NVIDIA's software ecosystem. Every breakthrough built on top of it runs through NVIDIA's tools. It is a powerful strategy. Dominate the robotics race without manufacturing every robot yourself. If the H2 represents the body, then Cosmos 3 represents the mind. And it may be the most important announcement NVIDIA made all week. Cosmos 3 is what NVIDIA calls a physical AI foundation model. Unlike traditional AI systems that primarily understand text, Cosmos is designed to understand how the real world works. Most AI models operate in language. Robots do not. Robots exist in environments where objects fall, doors swing open, liquids spill, and surfaces behave unpredictably. To function effectively, they need an understanding of physics, motion, and three-dimensional space. That is exactly what Cosmos 3 was built to provide. NVIDIA describes it as the world's first fully open Omni model. It can process text, images, video, audio, and actions within a single system. That final category, actions, is what makes it different. Most AI systems can describe what they see. Cosmos can predict what happens next. Show it a glass tipping off a table, and it anticipates the water spilling. Show it a robotic arm reaching for a handle, and it predicts the precise motion needed to complete the grip. Instead of merely recognizing the world, it understands cause and effect within it. The practical implications are enormous. Today, robots often require thousands of real-world examples to learn even simple tasks. Gathering that data can take months of filming, testing, and labeling. Cosmos changes that process. The model can generate realistic training scenarios on its own, simulating environments, predicting interactions, and creating synthetic data at scale. NVIDIA says this reduces training cycles from months to just days. Both versions of the model are already available. Cosmos 3 Nano serves as the lightweight implementation, while Cosmos 3 Super delivers the full experience. NVIDIA has also released training scripts and datasets through GitHub, allowing researchers worldwide to begin experimenting immediately. Alongside the launch, NVIDIA announced the Cosmos Coalition, a partnership involving companies such as Agile Robots, Black Forest Labs, Runway, and Skilled AI. Their shared goal is to accelerate the development of physical AI through open collaboration rather than isolated competition. The final announcement shifted focus away from robotics and towards something millions of people use every day: the personal computer. NVIDIA is entering the AI PC market in partnership with Microsoft. The new platform is built around a processor called RTX Spark, which combines a Grace CPU and a Blackwell RTX GPU into a single integrated package. The specifications are staggering. RTX Spark delivers up to 1 petaflop of AI performance and supports as much as 128 gigabytes of unified memory. That memory figure is especially important. Large AI models require enormous memory capacity to operate efficiently. Until recently, that capability was largely confined to expensive data centers. RTX Spark changes that. According to NVIDIA, the platform can run AI models containing up to 120 billion parameters locally, with context windows reaching 1 million tokens. Workloads that once required racks of server hardware can now fit on a desk or inside a backpack. The implications go beyond performance. Most AI tools today rely on cloud infrastructure. Every request must travel to a remote server. That introduces costs, latency, privacy concerns, and dependence on internet connectivity. With RTX Spark, those models run directly on the user's machine. The result is faster response times, greater privacy, and full functionality even when completely offline. NVIDIA believes AI agents will become the primary way people interact with computers in the future. Instead of navigating menus and applications manually, users will assign goals. The AI will then execute tasks autonomously, potentially working for hours while the user is away. That vision requires enormous local computing power. RTX Spark is designed to provide it. And it is arriving at scale. Asus, Dell, HP, Lenovo, Microsoft Surface, MSI, Acer, and Gigabyte are all expected to launch systems built on the platform. NVIDIA anticipates more than 30 laptop models and roughly 10 desktop configurations beginning in fall 2026. Viewed individually, the H2 Robot, Cosmos 3, and RTX Spark are impressive products. Viewed together, they reveal NVIDIA's long-term blueprint. Cosmos 3 teaches machines how the physical world behaves. The H2 provides a physical body capable of acting within that world. RTX Spark brings the computational power needed to run these systems into devices people can actually own. This is no longer a company focused solely on selling graphics chips. NVIDIA is building the infrastructure layer for the physical AI era. The software, the hardware, the training models, the development platforms. Everything needed to create intelligent machines that can see, understand, reason, and act in the real world. As the executive director of Stanford's Robotics Center recently noted, robotics advances fastest when researchers have access to open platforms, shared software, and real machines on which to test ideas. This week, NVIDIA made all three dramatically more accessible. The next generation of humanoid robots will be built by teams capable of combining AI reasoning, physical understanding, sensor data, and real-world experience into a single system. And NVIDIA just handed those teams most of the tools they need to begin.